So let's get a few examples of integration done. Let's say we want to integrate 9x to the minus 3 by dx. Now we know that we have to add 1 on to the index and divide by that. So if we add 1 on to the index, we're going to have a value of minus 2. So it's going to be minus 9 upon 2 x to the power of minus 2. And don't forget to add in the value of c because it's an indefinite integral. Now again, you can always check and see that you've got this correct, because whenever you differentiate this, you should get back to the original function. So let's try differentiating this. We're going to be multiplying it by, we'll just write it down below. Let's say we differentiated this, it would be minus 2 times minus 9, which is plus 18. So that would be 18 upon 2, x to the power of 1 less than 2, which is minus 3. So this is going to be equal to 9x to the power of minus 3. So we've got it correct. Now you don't always have to go and differentiate it to check it, but it's just a first one we've done, so we'll do it as a little check. So let's try another one here. Let's say we're going to integrate minus 5. Now we'll change it to a different variable here, so we'll call it theta. Minus 5 theta to the power of 4 upon 3 by d theta. So again, we're going to add 1 on and divide. So when we add 1 on to 4 upon 3, we get 7 upon 3. So this is going to be minus 5 upon 7 upon 3 theta to the power of, well, it's 4 upon 3, so we're going to add 1 on, so it's going to be the value of our 7 upon 3, so it's theta to the 7 upon 3, all plus some constant c. So we can then rewrite that as, when we divide by 7 upon 3, it's the same as multiplying by 3 upon 7. So that's the same as minus 3 times 5 all upon 7 theta to the power of 7 upon 3 plus c. So that's equal to, well, 3 times 5 is 15, so it's going to be 15 upon 7 theta to the 7 upon 3 plus c. And again, we should actually double underline our solutions. So let's go and we'll try another 2 of these, okay? So let's try this one here. We have the integral of minus 15 s to the power of minus 2 plus 10 s to the power of minus 5 upon 2 plus 5 s to the power of minus 3 all by ds. So go ahead and pause the video and see if you can get the answer to this. So that's going to be, we add 1 on to the power, becomes minus 1. The minus cancels out with the minus. We'll have 15 s to the minus 1. And this one here we add 1 on, so that's going to be minus 3. So it's going to be 10 upon, and it's going to be the 3 upon 2 and a minus sign here because it's minus 3 upon 2. That's s to the power of minus 3 upon 2. Now finally here we're going to have minus 3, so we add 1 on, becomes minus 2, and then we divide, so it's going to be minus 5 upon 2 s to the minus 2, and of course it's all plus c. So let's put this in a bit simpler form. So that's going to be the same as 15 upon s, and this is going to be minus, well, whenever you divide by 3 upon 2, it's the same as multiplying by 2 upon 3. So that's going to be 20 upon 3, and it's going to be, I'll just leave it at this moment, s to the minus 3 upon 2, and this is going to be minus 5 upon 2 times, now s to the minus 2 is same as s squared plus the c. So we'll just change this one section here and that's us finished. So it's going to be 15 upon s minus 20 upon 3. Now that's the same as s to the power of 3 upon 2 on the bottom line. So that's going to be the cubed root, that's going to be the square root of s, which is s to the power of, I'll rub that out. Okay, so that will be s to the power of 3 minus 5 upon 2s squared plus c. So hopefully if you've worked that out, you should get the same answer as I have, assuming that I've done it correctly. So let's look at another one. So let's look at this one here, the integral of 5 plus p to the power of a half minus p to the power of 3 upon 4, all divided by the root of p by dp. So go ahead, pause the video and see if you can work this one out. So we don't want the root p in the bottom, so we're going to have to multiply by the p to the power of minus a half. So that there is the same as saying p to the power of a half, and when we take it up it becomes p to the minus a half. So it's the same as saying the integral of 5 plus p to the power of a half minus p to the power of 3 upon 4 all times p to the power of minus a half, and that's all by dp. So let's multiply this out. So that's going to be the same as saying the integral of, well, 5 times p to the minus a half. Now this one here is going to be p to the half. Now when we multiply these we add the indices, so it's plus a half minus a half is 0. So it's going to be plus p to the power of 0. And this one again is going to be minus, and when we multiply the indices we add, so it's 3/4 minus a half. So 3/4 minus a half is going to be 1/4. So it's p to the power of 1 upon 4. And that's all by dp. So we're in a position now that we can actually do the integration. So that's going to equal, whenever we integrate it, it's going to give us, well, we add 1 on here, so that gives us to the power of a half, and we divide by a half, so it's 5 upon a half p to the power of a half. Now p to the power of 0 is just 1, so whenever we integrate 1 we get back to just the value of p. And this one here we're going to add 1 on to the index, so instead of being power of 1 upon 4 it's going to be 5 upon 4, and we've got to divide by 5 upon 4, so it's going to be p to the 5 upon 4 divided by 5 upon 4. So we'll rewrite this out, and it's going to equal, well, 5 divided by half, a half is the same as 5 times 2, so that's going to be 10, and p to the power of a half, we'll just write it out, and is 10 root p plus p, and this one here is going to be minus 4 upon 5 p to the 5 upon 4. So I could write this one here in this terminology here, so that finally we could write it as 10 root p plus p minus 4 upon 5, and we're going to have the 4th root of p to the power of 5. So let's double underline that. Now hopefully if you've done it correctly and I've done it correctly, we've got the same answer. But I haven't got this quite right. Can you see the mistake that I've made? And this is a mistake that people tend to make when they're first starting out. We've missed the constant. It has to be plus c. So that there is actually the final and correct answer.